Hi, so I'm Dolma,
And I'm Maya.
and we're doing ocean acidification and how it impacts the marine life.
So what is ocean acidification? Ocean acidification is the absorption of carbon dioxide in the atmosphere. Carbon dioxide that is released by predominantly greenhouse gases into the ocean due to various polluting activities. The most significant being the burning of fossil fuels, as I said, and activities to produce energy.
So our research question is, how is marine life affected by the surplus of CO2 in the atmosphere? And the problem is, ocean acidification is the increase of acidity in the ocean due to large amounts of carbon dioxide emissions released from burning fossil fuels, which are absorbed by the sea. The increasing CO2 levels has been shown to significantly reduce the ability of ocean organisms to produce their shells and skeletons, which reduce their chance at survival, thus putting many species in danger of extinction.
So here's our model. So it shows that carbon dioxide, 30% of it is actually absorbed by the ocean, which is a huge amount. And when water and carbon dioxide combine, they form carbonic acid, which is a weak acid that breaks into hydrogen ions and bicarbonate ions. This causes a decrease of available carbon ions, which are the foundation of shells and skeletons of various ocean organisms. The increase of CO2 also causes the average pH levels in the ocean to decrease, which leads in increasing acidity. And oftentimes this causes shells to dissolve. Due to the low pH levels, acidity dissolves the calcium-based shells of various sea creatures, and currently pH levels are 8.1. However, over time, as it decreases, the ocean will become more acidic, as we see. It's kind of been a trend that pH has been relatively neutral for the past 20 million years until really the Industrial Revolution, where pH levels suddenly began to decrease.
So because the organisms in the ocean produce their cells and skeletons through the use of calcium and carbonate seawater, the acidification of the water can cause carbonate ions to bond with hydrogen, meaning that fewer carbonate ions are available for calcifying organisms. Organisms can maintain their shells, skeletons, and other calcium carbonate structures through the help of calcium carbonate, but if the pH levels are too low, skeletons will start to dissolve. The graph shows that the average change in mass of shells as the pH solution in the seawater decreases, and the dotted points display the dependent relationship between sea creatures and pH levels who lose mass in their shells as pH decreases.
So we have two solutions. Our first solution is introducing beds of seagrass to ocean organisms to protect them from acidity. So basically, as we know, CO2 is emitted into the atmosphere, which is then absorbed by the sea. And basically what seagrass does is it conducts photosynthesis, so it absorbs CO2, and through the chloroplast it uses light energy to transform CO2 into oxygen. So it kind of serves as a buffer for ocean acidification, which will protect marine life to an extent.
So a study done at Oregon State University by Professor Wald Busser was where they planted baby oysters in a bay, which discovered that oysters placed in beds of seagrass were able to grow and thrive, while those outside didn't survive through the acidic conditions. The eelgrass absorbed carbon dioxide from the ocean, which allowed the oysters to grow, but nothing outside the beds of eelgrass survived. The beds of the seagrass rose pH levels in the ocean as they conduct photosynthesis, which allowed the oysters to grow with no harm.
So there are definitely more pros than cons, as the cons are just dependent on kind of natural natural effects like temperature and daylight. So it is quite inconsistent because you never know when the full effect of the seagrass is going to take place, because once again it's dependent on natural features which are unreliable. And pros, as we said, it's a huge amount of it's a huge change, 30% decrease in acidity. So that's only 1 unit of pH, but yeah, 30%. And as we said before, the ocean absorbs 30% of all carbon emissions. And it's also a natural solution, and it's not harmful to the environment. So our second solution is reducing the use of carbon-oriented energy sources. So using renewable energy sources such as wind energy and solar energy would drastically decrease carbon emissions if they were to replace fossil fuel energy, because when carbon dioxide levels in the atmosphere decrease, obviously less is being absorbed by the ocean. So this is a way of attacking the source of the problem. So it's a more efficient and long-term solution, and kind of an irreversible one. So if we were to completely replace renewable energy sources, it would overall cause a decrease in all these issues.
So the burning fossil fuels, such as coal, oil, and gas, are some of the driving factors of climate change due to the release of CO2 emissions in the atmosphere. By attacking the source of the problem, it would provide a more effective and long-term solution, such as renewable energy sources, for example, solar energy and wind energy, that could replace the use of fossil fuels and significantly reduce the amount of carbon dioxide in the atmosphere and the ocean.
So there are a lot of pros and cons. Pros being obviously decreasing global warming, improve public health, so less pollution. It's inexhaustible energy, so the energy is from sunlight and wind. It provides jobs and many other economic benefits because there's more jobs to go around, because there's more units for these energy sources. Stable energy prices. So basically, it's been shown that prices have actually been decreasing for solar energy, and it's also a more reliable and resilient source, as it doesn't require much maintenance, as once again it's dependent on natural sources of energy. And probably the most beneficial is that one of the most beneficial aspects of this is that it gives a wider access to energy, as many of these energy sources are placed in rural areas, giving many places the opportunity to develop.
So the cons is that there is insufficient amount of energy capacity, and can also be very unreliable.
Yeah, because of weather and
and it will initially be extremely expensive. The more that's needed, the more expensive it will be, and it still generates pollution, but less than fossil fuel. In fact,
yeah, it won't be to the scale at which fossil fuels generates pollution.
Okay. Referring back to our problem, the solution would allow referring back to our problem, research displays that the beneficial role of seagrass when introduced to a marine environment, as it conducts photosynthesis, which reduces CO2 levels. Grass, such as grass ecosystems like seagrass, can raise pH levels by more than 0.1 unit, which is equivalent to a 30% decrease in acidity. While the solution is efficient, reducing carbon emissions is a long-term solution that attacks the root of the problem, which is excess greenhouse in the atmosphere. Less CO2 absorbed by the ocean would decrease the amount of carbonic acid, as well as increasing pH levels in the ocean, which would ultimately lead to a better environment for organisms. Renewable energy would be a big step in reducing the amount of CO2 in the atmosphere and the ocean, and despite minimal emissions, global warming would dramatically decrease.
Yeah, and to refer back to our initial problem, which was the effect on marine life, both of these solutions would allow ocean organisms, particularly with shells, to survive and thrive where they are, and so they are able to reproduce, which kind of ensures the survival of and the existence of various marine life species. Thank you.
And these are our citations.
Thanks.